Alright, so our next gravitational example is asking you to calculate the acceleration due to gravity on the moon. So I have an alien stands at the surface of the moon. I ask what is the acceleration due to gravity of the alien on the moon. So we see we have a lovely little alien, me showing off my artistic prowess here. This drawing is obviously not to scale. The only information that you have on this is the mass of the moon. You have the radius of the moon. We don't know the mass of the alien. Of course, we know the gravitation constant is 6.67 times 10 to the negative 11th. Remember, that doesn't matter where you are in the universe. That gravitational constant is always going to be 6.67 times 10 to the negative 11th. So what I'm asking you to solve for is what's the acceleration due to gravity? In other words, what is g on the moon? We don't know that. So in order to do that, we're going to have to take a look at and analyze the gravitational field on the moon. So we're going to start off with the equation that pretty much governs everything we do, good old F equals m times a. So as we look at this, I'm asking you to solve for obviously the acceleration. I want the acceleration due to gravity. Well, we look at this, we are going to calculate the force of gravity on the moon using big G, m1, m2 over r squared. And let's go in and actually put values here. That would be big G is equal to the mass of the moon itself, so we'll call that mm, times the mass of the alien, that's going to be our other object, over the radius of the moon, rm squared, and that's going to be equal to the mass times the acceleration. Now we ask ourselves what object would be the mass we're talking about as we're looking at what's being acted upon, and that would be the mass of the alien. So we'll put a, mass of the alien, and then instead of acceleration, let's call it g, because that's what we're trying to find, what's the gravitational acceleration on the moon. So we look at a little bit algebraically here. Guess what? Mass of the alien is going to cancel out, so we're left with g is equal to big G, gravitational constant, mass of the moon over radius of the moon squared. So this is once again another equation that you're going to need to remember, is not necessarily just for the moon, but any object. To calculate the acceleration due to gravity is g is equal to gravitational constant, capital G, times the mass of the object you're standing on over the radius of that object squared. So if we were to do that and then find that value on the moon, we would find that the acceleration due to gravity on the moon is 1.63 meters per second squared. So that's simply just plugging in our values that I had check marked over here, the mass of the moon as well as the radius of the moon. There you go. Well, let's take this a little bit further. So let me get a new page here. And I'm going to ask if the alien, so part B here, I said the alien has a mass of, let's go with 20 kilograms. What's his weight? So we look at this, I could actually do this a couple different ways. We know weight, force of gravity, is always equal to mass times acceleration due to gravity. So I can make this really easy on myself and just take the mass, 20 kilograms, times the acceleration due to gravity on the moon that we just solved for, 1.63 meters per second squared, and I'd get right around 32.6 newtons. Or there's another option, let's call it option 2, What if I didn't know the acceleration due to gravity on the moon? Well, weight is once again just equal to the force of gravity, which we know is big G, m1, m2 over r squared. So I would be talking about the mass of the moon. Let's not write mass. Let's save a little space and let's go, boop, we're talking moon. We're talking alien. And then we're talking radius of the moon. So we plug that in, and guess what? We get the exact same thing, 32.6 newtons. How about that? So just another way for me to ask you, well, another question. I ask what's his weight, which is really just force of gravity, just taking good old F equals m times a, or using our new gravitational formula, force is equal to gmm over r squared. Thanks. Have a great day.